Okay, seventh period, as you can see, I am not here at the moment. I do have an engagement that I actually have to be at currently. But you all know how to behave appropriately, especially coming from my pre-AP class. So I expect no negative reports from the substitute from this class. If I do get a negative report, I'm pretty sure you've heard from my second period pre-cal class what their punishment was whenever they decided to act a fool. The same will apply to you. No one is allowed to be at my board. This should be a new section that I am introducing to you. No one is up and about. Everyone should be at their desk listening to this video. Also, I may or may not arrive right before the bell rings, or maybe exactly when the bell rings. However, I will be here right after school for those that need to stay for tutorials. Again, it's just an engagement that I had to go to. Either I'll be back exactly when the bell rings, a little bit before, or I will be back, but maybe 5 to 10 minutes past the bell. So if you are interested in staying, stay put, and I will be here. I will be back in my room as soon as I can. With that said, let's go ahead and move on to section 1.4, which is entitled Functions. We're done with 1.3, which covered slopes. You have a quiz over 1.3. Remember that I decided to move it up a day, so it will actually be on Thursday. So you have a section 1.3 quiz on Thursday. Okay, so let's go over some basic vocabulary with functions. Again, this should be a review for everyone because you've taken Algebra 1. And I'm going to go over some 3 basic definitions and 3 more definitions for you all that you may know or you may not know. Let's go over the 3 that you should know. And the first one is a function. The short and simple definition of the function word is that for every x, there is exactly one y and one y only. So for example, if I substitute an x value, then that will output only one y value. In other words, you can't repeat the x, because once you choose an x value to be a certain number and it's going to produce, let's say, your y value, which is 5, then that means no other x value can produce that y value, which is 5. All right. So then after that, we also have domain. Some of you all have ingrained in your brain that domain is x. Domain is x. But a little bit more of a formal definition is that domain is the set of x values. In other words, pictorially or graphically, if I had a picture up on the board, you would relate the domain with what axis? The x-axis, that's right. Okay, and then of course, since you've taken Algebra 1 before, with domain always comes what? Range, good. So the more formal definition of range is that it is a set of y values. And again, pictorially or graphically, if you were to relate range to a picture, you would say you would relate it to the y-axis. Okay, so now with that said, I'm going to go over 3 more basic definitions that you may or may not know. The first one is implied domain. Now, implied domain is basically the set of all real numbers. And I'm pretty sure you have heard that expression before. What is the domain? All real numbers. Maybe you haven't heard the set of all real numbers, but at least you have heard all real numbers. All real numbers. And as you all know, us mathematicians are lazy. So instead of saying or writing all real numbers or the set of all real numbers, we have a little symbol, which is basically a double R. That's what we use as shorthand notation for the set of all real numbers. Okay, an example of this are basically all polynomials. So all polynomials typically have the set of all real numbers for their domain. Example, a polynomial is something that looks like this. Let's see, y equals x to the 5th plus x cubed plus x. I'm just making something up here. That is a polynomial, plus x plus 1. Basically, a polynomial is where everything is on the numerator parts, because if you think about it, all of this I can really put over 1, and it's still just the same thing as that. So a polynomial is basically when you have different terms that are raised to a power. In other words, if I were to graph this, it would be some kind of curve that goes continuously in one direction and continuously in the other direction. So basically, anything in between in there is up for grabs for the domain. So the domain would be all real numbers. And more specifically, I believe the range would also be all real numbers if it didn't have a specific stipulation on it. So that is the definition of implied domain. Okay, another one which is probably the most important is you have to know what a rational expression is. That is very important. A rational expression is basically a fraction form of two polynomials. Okay, so remember, a rational expression is basically a fraction form of two polynomials. So let's give you a proper notation for this. Basically, let's say that I have some polynomial. I will call it p of x. And I'm going to zoom out so for those that didn't get the, there we go. Okay, so let's just say I have p of x. I'll call it some polynomial is over r of x. Now here we have to be very careful because again, the key word is rational as well as part of the definition, which is fraction. Remember that I said that a polynomial has all real domain. In other words, the set of all real numbers is the domain. But in this case, we have a fraction, and we have to be very careful with fractions because there is really one stipulation that we must always consider with fractions. And I hope someone can answer that for me. There is one thing that I had to be very careful. And what is that? Okay, if no one has gotten it, let's go ahead and go over it. But if someone did get it, good job for you. The stipulation that I have to consider is that r of x cannot be what? It cannot be 0. That's very important because if you were to get 0 on the bottom, that can't happen because you cannot have a division by 0. So that is one thing about rational expressions that you have to basically keep in mind and learn at least for the rest of your pre-cal and calculus career. A rational expression is basically two polynomials in form of a fraction in which the bottom polynomial cannot be equal to 0. Okay, that is rational expression. All right, the next one is a radical expression. Now, radical expression. What can we relate radical to in layman's terms? Basically, it's a square root function. So in other words, let's go over the parent function, and we're going to discuss parent functions later on. But the parent function, for those of you all that don't know, of a radical expression is the square root of x. Now, again, with radical expressions, we have to be very careful because there's a stipulation that we have to say in regards for us to be able to work with this kind of problem. Now, if you take a look at it, if it's in the x is in the inside of the square root or the radical, what stipulation must we place in there for us to be able to use or work this expression? Okay, let me ask you a question. Can you take the square root of 4? Yes, I think you can. Can you take the square root of 3? Even though it's not a nice number, you can. What about the square root of 2? I think so. The square root of 1? I agree. What about the square root of 0? Can you take the square root of 0? You can take the square root of 0. Okay, let me ask you one more question. Can you take the square root of negative 1? At this moment, no, you cannot take the square root of negative 1. So that right there should kind of give you an idea as to what our stipulation is. Our stipulation is that your x, and keep in mind, your x is related to what from the vocabulary that you just learned earlier earlier in this slide. Your x is in relation to your domain. So basically our stipulation is that our x value has to be greater than or equal to what? It has to be greater than or equal to 0. Exactly, because if anything is less than 0, then that means it's a negative inside that square root, and at the moment you cannot find that square root of a negative number. Okay, so just remember, we've discussed the implied domain, which is a set of all real numbers. We've discussed rational expressions, which are two polynomials in form of a fraction, in which the bottom polynomial cannot be 0. And we also discussed radical expressions. I gave you the parent function of a radical expression, and the most important stipulation here is that anything that's underneath the square root has to be greater than or equal to 0. So those are very important concepts you have to know. All right, so let's look at some example problems. The first one, let me go ahead and give you some time to copy that down. It says, tell whether the equations represent y as a function of x. Okay, so in other words, for whatever x value you may pick, do you only get one y value and one y value only? That's basically what you have to do. And if you do get one y value, then your answer is that it is a function. If you get more than one y value, then it's not a function. All right, so let's take a look at the first one. The first one is x squared plus y is equal to 1. All right, so what I want to do here is I just want to solve for y. In other words, I want to move that x squared to the other side. Now at the moment, this x squared right here is positive. But when I move it to the other side, it becomes negative. So let me go ahead and move it and get y equals 1 minus x squared. Okay, so now I really want you to think about it. Let's just pick a number. Pick a number for x. Let's say 5. All right, so if I were to plug in 5 in for x, I would say 5 squared, which is 25. 1 minus 25 gives me negative 24. So basically, I get that y is equal to negative 24. Is that only one y solution? That's right. I agree. We only get one y value when I plug in that x value. So, do you think this is a function? So in other words, for every number we plug in for x, do we get more than y out? I only got one y out. So the answer for this question, do we get more than one y out, is no, we don't. So since we don't get more than one y out, this problem here is indeed a function. And you'll see later on, I'm going to go over some more tests and some more techniques to help you determine whether it's a function or not. Okay, moving on to the next one. B. B is negative x plus y squared equals 1. So the first thing that I want to do is I want to solve for y. So let me move this negative x to the other side. When I move it to the other side, it becomes y squared equals x plus 1. Now that's fine, but remember, I'm not looking for y squared, I'm looking for y. So essentially, I have to root both sides. Now remember, in this semester,